In this video, we're going to look at multiplying numbers in scientific notation. And to help motivate that conversation, I have an example here. If one ant weighs 2/100ths of a gram, how much will 6 million ants weigh? Express your answer in scientific notation. So, before we get going on that, let's review scientific notation, what it is, what it looks like. A number written in scientific notation is going to look like this. It's going to be a times 10 to the b power. Now the number a has to be bigger than or equal to 1 or less than 10. And they throw in the absolute value here, so a could be a negative number. So example, if a was negative 3.2, then the absolute value of negative 3.2 would just be positive 3.2, and it would be between 1 and 10. So the absolute value here is just saying, hey, if you ignore the negative sign, that number a has to be between 1 and 10, or including 1. And the exponent, which we're notating as b, has to be an integer. So recall that the integers are basically positive and negative whole numbers. All right, these guys running out of space, dot, dot, dot. So this exponent could be a negative number, it could be a positive number, but it can't be a fraction or decimals. It needs to be a positive or negative whole number. So let's say we have a very large number. Well, let's go back and use the numbers that we have in our ant problem. So one of the numbers we have in our ant problem is that the ant weighs 2/100ths of a gram. So if we wanted to put this number in scientific notation, we need to create a number equivalent to this number in the form a times 10 to the b. So we're going to move the decimal 2 places this way, and that would give me the number 2. Now I would have to multiply 2 by something to end up with this number right here. And since it is a small number, it's going to be times 10 to the negative 2. Well, let's explore that a little bit further, all right? And I have some videos on scientific notation that go more in depth of what scientific notation means, so we'll just review it quickly here. So 10 to the negative 2 means 1 over 10 to the second, or 1/100th, which as a decimal is like that, 1/100th. So if I take 2 times 10 to the negative 2, 2 times 10 to the negative 2, that's the same as 2 times 1/100th, which is 2/100ths. All right, so 2 times 10 to the negative 2 is equivalent to 0.02. Therefore, 2 times 10 to the negative 2 is the scientific notation for this number. All right, let's look at the other number we have in our problem, which I think was 6 million, right? 6 million ants. So 6 million would be a 6 followed by 6 zeros. Now, if I wanted to write that in scientific notation, currently the decimal is here. It's not written. And I'd have to keep moving this decimal until I got a number between 1 and 10, which would be right there. I'm looking for my a value. So if I move the decimal 6 places, I get the number 6. So I'm going to write 6 times 10, and now I need to pick a power. So if I take 6 times 10 to that power, I end up with 6 million. And that is going to be equivalent to the number of places I moved the decimal, which is 6, right? 10 to the 6th power is a million. So this is basically 6 times a million, which is 6 million. All right, let's go back to our problem and write our numbers out. So we know that each ant weighs 2 times 10 to the negative 2 grams. And we have 6 times 10 to the 6th ants. So we are going to multiply these two numbers together to get the total weight of all the ants. Now, notice this looks like two different numbers, and maybe we're doing two things to two different numbers, but I mean, it is two different numbers. But notice what we really have here when we're in scientific notation are 4 numbers: 2, 10 to the negative 2, 6, and 10 to the 6th, and these 4 numbers are multiplied together. So I could rewrite this as 2 times 10 to the negative 2. Actually, you know what I want to do? I don't want to write this times anymore. Let's put a dot, because I don't want to get confused with scientific notation. So let's say I've got 2 times, let's try that again, 2 times 10 to the negative 2 times 6 times 10 to the 6. That's really what this is saying. So I need to multiply these 4 numbers together. And we're going to do this without a calculator, right? The idea is there's an easy way to do this so you don't have to use your calculator. Now, multiplication is commutative, which means we could switch the order. So I'm going to switch the order so the whole numbers are together and so the powers of 10 are together. And I also know that multiplication is associative, which means I can multiply any of these together that I want in whatever order I want. So I'm going to go ahead and multiply these whole numbers together. That gives me 12. And then I'm going to multiply these together, the 10 to the powers. This is where the scientific notation comes in and gives us a nice shortcut. We have an exponent rule that says if you have something to a power multiplied by that same thing to a different power, that you can find that product by keeping the base the same, the a value the same, and adding the exponents together, right? That's a little exponent rule. So I can use this rule to multiply 10 to the negative 2 times 10 to the 6. In this case, the 10 is like my a value, right? That's the base. And my exponents are negative 2 and 6. And I have some videos on, this is called the product rule. So if you wanted to learn more about why this works and see some more examples with the product rule, you could go search that. All right, so we're going to use the product rule, and we're going to multiply these together by adding the exponents. So I have negative 2 plus 6. I keep the base the same. That's key. A lot of students want to write 100 here, but that's not the case. You keep the 10 the same, keep the base the same. And we'll add those together. Let's see what we have here. We have 12. Now I'm going to change this times to the x for the times symbol just to kind of make it look like scientific notation. And you could have kept the x the whole way for the times symbol if you wanted to. All right, so this answer to our question looks like scientific notation, 12 times 10 to the 4th. But it's not in scientific notation exactly because, let's go back over here, this a value right here has to be between 1 and 10. Let's go look at what our a value is. Our a value is 12. That's not between 1 and 10. So what we have to do is change that to a number between 1 and 10. And there's a couple different ways you can do this, but let's do it this way first. This is kind of the long way, but it'll help you see what we're doing. If I write this number out in standard notation, it's going to be 12 times 10,000, which is 120,000, basically 4 zeros, all right? Whatever this exponent is tells you how many zeros. Now, if I was going to put this number in scientific notation, I would need to take my decimal and move it back this way, like that. So I'd have 1.2 times 10 to the 1, 2, 3, 4, 5, 10 to the 5th, because I'd have to move this decimal around the 2 and then add 4 zeros. All right, so that's one way to do it. You could take this number, write it out the long way, and then put it back in scientific notation. But as you get used to working with this, you can see that, okay, I have 12 here. I need this to be between 1 and 10. So if I move my decimal one place this way, then I'm going to get 1.2. But that's going to mean instead of moving the decimal 4 places to the right to get the answer, I'm actually going to now have to move the decimal 5 places to the right. So these two numbers would be equivalent. 12 times 10 to the 4th, taking a 12 and moving the decimal 4 places to the right, is equivalent to taking 1.2 and moving the decimal 5 places to the right. All right, so your final answer, you need to write that in scientific notation, which means checking out that a value and making sure that it is between 1 and 10. All right, well, I hope that helps, and good luck.